First collaboration we have with developer Kaki, and we really appreciate the show up. And I know there's rain, there's very bad traffic, and the train is not working. Right, so yeah, thank you everyone for taking the trouble to be here tonight. And of course, I think one of the first thing that probably you guys will be wondering is, okay, Spring. You guys have, you have Java developers here, and I guess everyone here know about Spring framework. Yes. Okay. But anyone here know how does Spring relate to Vmware? Not really? No? None? Zero? Oh, one? Yes. Thank you. So, so I'm here to actually kind of explain a bit on the relation itself. And first let me introduce myself. My name is Edric. I'm actually based in Malaysia, and I'm actually from Vmware Tanzu team. Right? So I'll go through a bit on what is Vmware and how Vmware relate to Spring, and also talk about what is Tanzu itself. Right? Okay. Okay, so VMware is actually a leader in open source community. I'm not sure whether everyone here have actually seen some of these logos or have used some of these open source tools. But basically, we do actually contribute a lot. We do actually contribute a lot on the open source tools, and Spring is definitely one of them. Right? So, any of the tools here looks familiar for you guys? No? Yes? Kubernetes, okay. So, a lot of the projects here are either lead or started by VMware or is highly contributed by VMware. Right? Kubernetes, as an example, we are actually the second largest contribution to the Kubernetes contribution itself, because it's open source, right? So it actually involves all the contribution from the open source community. So VMware is actually the second largest contribution to Kubernetes behind Google, right? So Google started Google started Kubernetes. Of course, they actually have the highest contribution on it. But we are actually one of the highest contributors. And besides that, also we have actually a lot of tools, a lot of open source tools that we actually contribute to as well. One of them is of course Spring. And we are also the CNCF, so we are actually the platinum member of the CNCF community itself, and of course a lot of the tools are all given to that particular community. Alright? So then what is Tanzu? Well, Tanzu is basically one of the divisions within VMware that focuses on helping the application development itself. Right? So there are two main things that we actually focus on doing. First is to actually improve the developer experience through all the tools that we actually contribute to. Right? It can be a combination of multiple tools. Of course, we have our own set of products to actually sell to our enterprise customers. But the main thing is that we want to actually help the developer community to actually build their software faster and more secure and at scale, right? That can actually scale to all the public cloud itself. And besides that, of course, we also, having said that we actually contribute a lot in Kubernetes, we actually have a whole platform of solutions that actually help run those applications itself as well. Right? So that's Tanzu. So Tanzu portfolio is really focusing on application and how application run at scale across multi-cloud, right? Not just one single cloud provider. So, of course, I won't take up too much time, but having said that, we contribute a lot on open source and developer community. We also have a lot of free applications that we actually push out as well. So these are some of the free applications that we actually publish, and you guys can actually access any of this. Right? So just go to the link. I think I'm not sure whether is there a way for us to distribute this slides later on, but we can just basically do a quick search on this. Cube Academy is one of them. The other one is the Tanzu Developer Center itself. And there are actually a lot of things in there that you guys can actually help gather and learn from the particular sites as well. Of Of course, besides that, we also offer actual courses. And in fact, there is actually a promotion going on for our spring courses as well. Right? So, if you are interested, please do reach out. Again, I have to here, I'm based here. So, actually, I have my email address posted earlier as well. So, you guys can actually drop me an email as well. Alright, so I said Tanzu portfolio is really to help develop application faster, easier, and also we actually have a consulting arm to actually help customers through the journey of transforming into more agile and more cloud-native type of development as well. Right? We call it Tanzu Labs. Right? So again, the focus is really helping not only from a technology stack perspective, but also in terms of culture and organization adoption as well. Okay, of course, I don't want to take up too much time. Our key speaker is waiting at the back. So please, everyone, welcome George to actually.
Good stuff. Can you see me? Can you hear me?
Yeah.
All right. Hi, everybody. How are you? Oh, I'm so happy to be here. You know how long it's taken for me to get here? It's just, I'm so happy to be here. Before we get underway, I was wondering if we could all take a little selfie together. Would that be okay? Yeah. Okay. Rock on. Now, people, what I want you to do is we're all gonna get ready, and then we're gonna say we're gonna pretend like we're happy. And then we're going to say open source, okay? Can you do that with me now? Okay, everybody. And a 1, and a 2, and a 1, 2, 3. Hold on, 1 minute. Pretend like you're happy. Ready, steady. Open source. Good stuff. I appreciate that. Thank you so much, my friends. You know, I'm going to take that photo. I take those photos. Whenever I'm on the stage, whenever I'm doing a keynote or a presentation, whatever, I take those photos of the audience, and then I take them home, and I show them to my daughter, and I say, see, they listen to me. She doesn't care. Doesn't care one bit. Okay, anyway, good stuff, my friends. We have a lot to cover in so very little time, so please take a seat, relax, make yourself comfortable. It's about 19:30, so we've got like 2 hours and some change to get through all this stuff. Here, my friends, is the most important slide you're going to see tonight. It is also the only slide that you're going to see tonight, so there is that. Here you'll find the coordinates for me and my information. I am Josh Long. I work on the Spring team. I'm a Spring developer advocate, a Java champion, and a Kotlin Google developer expert. And most importantly, friends, I'm at your service. So should you have questions, comments, feedback, whatever, just find me on the internet. I'm on Twitter. Anybody on Twitter? Anybody? No, it's like on fire right now. I don't know what's going on. What about Mastodon? Anybody using Mastodon? No? Okay, well, that's the new hotness. I don't know, it'll be okay. Email? Does anybody use email? Email. Does anybody use email? No. Good. Moving on. I'm not a fan either. It's a waste. Okay, so I'm on the internet. I have a blog. I have a YouTube series. I have a podcast every Friday, your time, Thursday, California time in the United States. I do a podcast episode where I talk to people that are smarter than I am. Now, granted, it's a very low bar. Very low, right? It's not hard to find people that are smarter than I am. But I do it anyway. And so every week I talk to people. And one of the things that I love talking to people about is how to build applications intended for production. I love production, right? You should love production. You should go as early and often as possible. Bring the kids. The weather's amazing. It's the happiest place on earth. It's better than Disneyland. But if you haven't been to production, you can begin your journey, as we will today, here, at my second favorite place on the internet, start.spring.io. Now, if you suffer from indigestion, a sour stomach, after a long night of alcohol abuse, start that spring.io. Or PHP. If you suffer from indigestion after a long night of PHP, start spring.io. If your children are restless and cannot sleep, start spring.io. And if you want to build awesome software intended for production, start spring.io. And that's what we're going to do, my friends. We're going to build a new application today. I can't really see the screen. There we go. Can you still hear me in the back? Fantastic. We're going to build a new application. I'm going to call this the Bootiful application. We're going to use the latest and greatest versions of Spring Boot, because Spring Boot 3.0, the GA final released version, is due very soon. In fact, Spring Framework itself is also due very soon. Here's Spring Framework 6, due on 16th of November. That's less than a week's time, friends. And Spring Boot 3 follows on weekends on the 24th. So my friends, today we're going to talk about building applications intended for production, but we're going to do so through the prism of this incredible new generation of Spring being released this month. You are in the right place at the right time, my friends. There's a lot of amazing opportunities implied by this new release, a lot of implications in this new release. So we're going to use that so as to have an easy way to look at things. We're going to build a service because, I'm lazy with names. We'll just use that. And then, friends, down here, as always, we have a choice, a seemingly impossible choice. Which version of Java would we like to use in 2022? Now, friends, Spring Framework 6 and Spring Boot 3 both require Java 17 or later. So already, 2 of these releases are out of the running. They're no longer valid. They're unacceptable. I like Java 17 because it's the current long-term supported GA version of Java. Java 17 is a great release. How many of you are using Java 8? Don't worry, we all did it once. We all tried it once. Nothing to be ashamed of. Nothing to be ashamed of. There's a little bit to be ashamed of. Like a little bit. It's a lot. There's a lot to be ashamed of here, friends. I really should have said that first and then asked. But I didn't. I did it the other way around, and I'm sorry. Who's using a good version of Java, like 17 or later? Oh, that is awkward. That is awkward. Friends, we need to do better. Java 17 is amazing. It's an amazing release. It's the current long-term release. And remember, Java 8, while it may seem, fairly new, it was actually released in 2014. Right? It's 8 years old. There's been 8 years since Java 8. Think about that. Doesn't that hurt? Java 17 is just better in every way. It's the current long-term supported version of Java, and it might seem a little controversial to require that everybody be using Java 17 in the new Spring Framework 6 generation. But consider how rarely a new generation of Spring comes along. The last major release, the last new generation, was released in September of 2017, more than 5 years ago. That release supported Java 8, and so we've supported it ever since. Here we are in 2022, and you can still write Spring Boot 2.x and Spring Framework 5.x applications using Spring Framework 5.x, and you can use Java 8. That's an amazing thing. It's a long tail of backwards compatibility. And the same, I expect, will be true of Spring Framework 6. Now, I can't see the future. No one can. But just extrapolate out a little bit. Suppose that we reunite here, well, hopefully sooner than that, but suppose we also reunite at some point 5 years hence here when Spring Framework 7 comes out, right? By that point, remember, they release new versions of Java every 6 months. Every 6 months, friends. That means that every 6 months from here on out, there will be a new release. There will be 10 releases. And remember, Java 17 isn't even the current major release of Java. There's already Java 19. That's a GA release version of Java. So we'll have 10 more releases on top of Java 19. You could be writing code using Java 29 and Spring Framework 6, Java 30, who knows, and Spring Framework 6. And some of you might still be writing code using Java 17. You're going to be very silly at the party. People are going to laugh at you. It's very weird. Java 17, my friends, is technically superior in every single way. It's faster, more performant, more operations friendly, more container ready, more robust, more syntax rich, more secure, more syntax rich. It is technically superior to Java 8 in every single way. It's also morally superior to Java 8. You will not like the look of sadness and despair in your children's eyes when they find out that you're using Java 8 in production. Don't do this. Be the change that you want to see in the world. Do the right thing. Use Java 17 or later. Java 17 is the right thing to do in 2022. And judging purely by the version number alone, my friends, the version number alone. Judging purely by the version number alone, I think we can all agree that Java 17 is more than twice as good as Java 8. That's facts, friends. That's facts. Right? It's definitely twice as good, at least. It's at least twice as good. I think we're on the same page here, people. So, I'm going to leave this as it is. I'm going to build an application that uses an in-memory SQL database. I'll use JDBC because, why not? I'll bring in the Spring Web support. I'm going to bring in the Spring Boot actuator for observability. And with those selections, I think I'm happy. I think I'm going to just go ahead and hit generate. And that'll give me a zip file that I can open up in my IDE. So service.zip, here we go. It'll load your IDE. And it doesn't matter what IDE you use, so long as it supports Maven or Gradle and the version of Java that you just selected. I've just selected Maven. But notice that here in the Spring Initializer, start.spring.io, there's a new change in town. See, if I go to an incognito mode browser with none of my plugins, you'll notice that the default version is Gradle. The default version is Gradle, and that's fine. There's nothing wrong with that. I just don't know enough to want to do a demo on stage about it, right? So, and I'm not the only one, people. I'm not the only one. So there's even a plugin. Somebody, when we switched the default version to Maven, when I found out that Maven is not the build tool anymore, I can't leave it like that. And then he built a browser plugin, a Chrome plugin. To change the default back to Maven. And so I have this plugin because I'm a coward. I don't want to do that. So Maven it is, okay? We have a zip file, and I have a project build here, service. And now I'm going to build just a regular application that reads data from a database. So let's do the first thing, obviously. We'll create a schema. We'll create a new file here called schema.sql. And I can't see the thing. Okay, there we go. I'm going to create a new file called schema. Let me see. There we go. Create table. It's the worst. Create table customer. Create table. Can you hear me now? Still? Okay. Create table customer. ID, serial, primary key, name. Woo. Var car. Woo. Okay. Var car 255 not null. All right. There's our basic schema, and I want to be able to have some data in the database. So I'll create another file here called data.sql, and I'm just going to initialize it with some customers. Insert into customer. And then some names. And so now, my friends, it's time for some audience participation. I need some names. My friend, what's your name? You don't have to tell me, but if you wouldn't mind, I would love it. How do you spell that, my friend? Like that? Very nice to meet you. Amen. Who else? You, buddy. What's your name?
Josh.
Really? Like the passion? Wait, Josh, like this?
Yep.
Oh, that's a good name. Compliments to the chef. Who else? You, buddy, what's your name? DHHI? Like this. Groovy, is that right? Oh, like that. Very good. Okay, let me see, who else? You buddy, what's your name? What is it? No! No, thank you. Get out of here. Let's see. You buddy, what's your name?
Jiale, Jiale.
J-A...
Iale.
Like that?
No, Jia.
J-A... Wait.
Jia. Le.
J-I-A... Like this?
Yep.
Woohoo! Good stuff. Okay, that's 4 names. This is a lot harder than I thought it would be. Let's get some more names though. I want a nice round number. Don't all raise your hand now at once. Who wants to be my next volunteer? Oh yeah, him. Yeah.
Marcus.
How do you spell that?
M-A-R-C-U-S.
M-A-R. Like this?
Yeah.
Oh, whoop, M-A, sorry. Marcus, like that?
M-A-R-C-U-S.
Is it?
Correct.
Is it really? I think I made a mistake and you're just being very nice. Okay, well, I'm sorry. Miss, what's her name? What is it? C or K? Like that? Very good. Nice to meet you all. Let me see. That's 6. Oh, we can do this. We've only got a couple hours, but we can do this. Let me see. 2 more. Let me see. I'm Josh. There you go. That's 1 more. And then, wait, we already got Josh. Darn it. I need some more. I can't even use my own name. It's not a it doesn't work. We've got. What is it? Ignition. Like this? C-I. Like this? Very cool. Okay, we're so close. We're so close. 1 more name. Who wants to be? Yeah. Yeah. Again? Okay. U-D-H. Like this? For real? Levenstein distance of 1? Okay. That's cool. It's cool. I dig. Okay, so let's go here to our application. Thank you, by the way, for everybody. It's super cool that we can all do that together. And we're going to build an entity to represent the StateNet database, and we're going to build a simple service, right? So just a very simple service. And by the way, isn't this nice? This is a record in Java 15. Look. Look, Mom. Little Mama. Isn't that nice? That's so nice. So this is an entity, and I'm just going to work with that entity. I'll say add service. And I'm going to create some methods that give me all the data in the database. Okay, so customer, all, and then I'll have another one here, collection, customer, by name. Okay, string name. Good. And of course, in order to use this, I'm going to use the JDBC template, right? The low-level, old-school JDBC template that you've no doubt heard about before. Nothing super fancy here. Just using that. Why not? And we'll say return this.template.query. Select all from customer where name equals this. And in order for this to work, I need a row mapper. Right? This is an old-school abstraction. It's been around in Spring for many, many, many years. 20 years. New row mapper. Okay, and I'll say return a new customer, result set get int for the ID, result set get string name, and voila. Okay, there's my basic row mapper, and I'm just going to use that here. This dot row mapper. I'm going to pass in the name as a parameter. Good. Now what about this one? Same thing, right? This dot query select all from customer. Customer, this dot row mapper. Good. So I've just got these 2 endpoints, these 2 methods. I've got this entity, this detail. Now I want to create a HTTP controller to surface that information. Okay, so class customer HTTP controller, private final customer service. Good, and we're just going to inject this into the constructor and create an endpoint that returns all the data as we ask for it. Okay, so turn this .template all, and we're going to create an HTTP controller, right? So git mapping customers and git mapping. Okay, git mapping customers name. All right, so not a big deal. You can kind of understand this is all traditional stock standard Spring MVC, been around forever. Right, path variable string name. This dot service dot by name. Okay, so that's our basic HTTP controller. Let's just go ahead and start this up and see what happens. I'll go ahead and restart. Here we are. Localhost 8080 / customers. Voila, there we are. We happy few, all 8 of us. It worked. Of course it worked. It was a demo. It was always going to work. That's not why we're here, my friends. What I really wanted to talk to you about is some sad news, actually. This ASCII artwork is amazing, right? There are people on the Spring team, people who have PhDs, people who are doctors, who worked in their previous lives in nuclear physics, star stuff, the very celestial bodies, and the heavens above us were their daily bread and butter. And so it's for this reason that I take great pride in imagining that someday, somewhere, somehow, there was a GitHub issue, and they said, hey, we need to have great ASCII artwork, and I think you can agree they did a great job. Great job. Now, some people, arrogant people, some people, they think they can change, they should change the banner. So did you know you can do this?
Yeah.
You can say like, hello, right? And then run the application again. And there's the, the new banner, right? Now, of course, I would never do that. That's a terrible idea. And that works, that feature still works, but did you know that if you create a Spring Boot 2.7 project, UAO banner.txt, and copy desktop banner.gif into banner source main resources. Okay, everybody get off the internet. Oh dear. Oh dear. Oh geez. This is going to take a minute. Did you know that in Spring Boot 2.7 we can do a lot more? You can actually take an image and convert it into text on demand. Whoa. Come on. This is worth it, trust me. It's going to be fine. It's fine. I mean, they probably just released a new point release while I've been on stage, Like, over here in Asia, they were so far ahead of the day. Everybody else is just waking up and having coffee everywhere in the world. Okay, wait for Maven import completion. Wow. You can see it's downloading everything. Everything. Like Maven itself is downloading stuff. Well, this is awkward. Okay. I'll let that finish. So that's, goodness. Okay, so banner, Maven, Spring Boot, run. And by the way, before we do this, CD banner, CD source, so open source main resources, banner.gif, Chrome, banner.gif. This is the banner, right? This is awesome. It's all the different Spring projects, Spring Cloud Data Flow, Reactor, and of course Spring Framework itself, Reactive Spring, Spring Cloud Data Flow, etc. Spring Cloud, all that good stuff, okay? So now, I'm gonna run this banner project. Here we are, downloads banner, Maven, Spring Boot, run. Yeah, it's awesome. I flew here just for that. Good night. say, this is not great for serverless. Don't use it there. And so this, my friends, brings us to the first bit of bad news, which is this banner feature, this animated banner feature, is going away. Oh, I know. It's been a hard 3 years. First the pandemic. I mean, this is not even close to that, but, you know, it's very sad. Okay, so, anyway, that's the first bit of bad news. And I just wanted to get that over with right now. While it's still top of mind and we can still have fun tonight, okay? So, the banner feature is going away. You can still have good ASCII, right? You'll have great banners by default. Look at that, gorgeous. Absolutely amazing. We can agree that's great, right? Good stuff. So, we have an HTTP application. We have data. Let's check our endpoint here. Localhost customers, and let's search for this gentleman here. Woo. Okay, and there we go. We got one by ID as well. Good stuff. Now, what if, you know, did I do this right? I think I did it right. Let me just make sure. All the letters are capital letters, right? So I want to insert some sort of validation logic that says, hey, if you request a name and the name is not uppercase, then it's not okay, right? So name does not equal null, and character is uppercase, name dot card at 0. Okay? So if not good, well then I want to throw an exception. I want to say throw new illegal argument exception. The name must start with a capital letter. Okay? So I'm doing some very basic validation here. Now, let's see what happens if I do that. Okay, we'll restart. If I restart this works just fine, right? Let's go to the command line. Curl works fine. What if I do the wrong thing and I lowercase it? Right? I get this error, internal server error, and it's very generic, very boring. This error is fine, and you can see I've got an exception here, the output. But the problem is, errors should be consistent. API users should have a consistent way to represent your errors, to understand your errors. So in Spring Framework 6, we have enabled support for problem details. Okay, problem details is an RFC. It's a standard way of representing errors. Small thing, but it's a nice thing. And so you can do this. Now I want to centralize my error handling logic. And of course, this is not a new thing, but you can use controller advice. I can say problem details, error handling, controller advice. Okay? And I'm going to create an exception handler, public void handle, and it'll be a legal argument exception. Okay, good. And my job here is to handle the error, but I want to handle it in a consistent way for all controllers in my application. So this controller advice class gets a chance to respond to exceptions. So here I'll say problem detail for status 503, let's say, and we can just use the message IAE.getMessage for this detail. Okay, so let's go ahead and restart this. Okay, so now you get this standardized output, right? Instance, detail, status, title, etc. Right? Good stuff. Pretty simple, but good stuff. Now, I'm all about making my application more robust. And to that end, it's always useful to kind of get access to the context to see how things are working. So let's inject the servlet request, and we can inspect its output when the application has an error. Okay? So what I'm going to do is I have the request, and I want to get the attribute names, and I want to go through each one. So A, N, and then for each one, I just want to print out the result. So like this, like that, and we'll say request.get attribute names, get attribute, okay? So I'm just printing out the request attributes as the application encounters an error. So we can kind of see that here quickly. Nothing special about this, but let's just make sure we understand what's happening. Okay, so there we go. We have all the attributes that are in the application context, in the request context, etc. Not a big deal. What is interesting here is this type. Notice that this is a regular servlet request, and yet the package is different. you've ever used this API before, you're probably familiar with javax.servlet.http servlet request. It's changed, right? Now, I don't want to get into all the details here, but suffice it to say, about 5 or 6 years ago, what's the easiest way to say it? 5 or 6 years ago, Oracle stopped responding to emails for Java EE, right? And eventually, the community managed to get them to open source the types. And they did so, but only under one stipulation, that any changes that you make to these new types have to be in a new package, right? So that means that every piece of code ever written against the servlet specification or JPA or JMS or anything like that breaks. 20 years of Java EE, J2EE, all that stuff is now broken. Technically, however, there's not much we can do. It's a political problem, not a technical problem, right? But the good news is the Jakarta EE folks, the technical people over at the Eclipse Foundation, have done an amazing job, technically, at making this migration as painless, without pain as possible, right? So they released a new version of Jakarta EE with the old Javax namespace, JAVAX namespace. Everything is exactly the same as it was before. They just released it under this new open source license. And they released new documentation and new tests and all that, right? Because that wasn't open source. Then they released another version of Jakarta EE, but this time with the package changed. So nothing changed, nothing new, nothing happened, but the package changed. So now there's 2 versions with no changes. So it's basically there were 3 versions. There's Java EE 7, which is the old JCP, Oracle-controlled Java EE. Then there's Java EE 8, which is the same, just a new license. And then Java EE 9, which is the same but a new package. And then now we have 10, which actually has some features. So it's been like 5 years without any major features. But that's because they're trying to make it as smooth as possible for people to adopt the new types. And that's been a big thing that we've been working on, right? Apache Tomcat, Hibernate, Netty, all these frameworks that depend on these Javax types had to be updated. And that's what you're going to see here. When you upgrade your code to Spring Boot 3, you'll see this. But it's just a find and replace. Whenever you see Javax, just replace it with Jakarta, you'll be fine, okay? So that's another piece of bad news that, like the banner, I feel will impact a lot of people. Okay, I just wanted to bring that up. Okay, so we have our application. I want to observe what the application is doing, and to that end, I have included in my build the Spring Boot actuator. The Spring Boot actuator gives me managed HTTP endpoints that allow me to see what the application is doing. So I can say, show the health details, I want to expose all the management endpoints, I want to enable the Kubernetes probes, I want to make sure my application does the right thing in a production environment, like Kubernetes, right? So I'm going to restart the application. This you probably shouldn't do for everything. You should probably lock down, but for our demo, I'll expose everything. And then you can go to here, localhost 8080 /actuator. And the actuator are, like I said, several different HTTP endpoints. You've got like your health endpoint, you've got env, which shows your system properties and environment variables and all that. You've got config props, which tells you config props, which shows you system properties and things like that. You've got metrics. Metrics are statistics. These are keys and values related to your application. These are useful for understanding how your application in total is behaving across all the requests. What is the latency, the 95th percentile, etc. These metrics are very useful, and they're powered by a project called Micrometer. Micrometer is a vendor-neutral application metrics facade, and it has a number of different integrations, including Prometheus, which is very common in the Kubernetes space, right? Including Humio and Graphite and Ganglia, StatsD, Stackdriver from Google Cloud, VMware's own Wavefront. All these things work well as a time series database with Micrometer. So Micrometer is actually everywhere, right? Lots of different libraries use Micrometer for instrumentation. Drivers, database drivers use it. Message brokers use it. It's like Log4j, right? Every library wants to export metrics related to the functioning of those libraries. And so it's very natural that they would depend on Micrometer. And in fact, that's how it kind of works, right? If you think about it, micrometer sits at the very bottom of the stack, like along with log4j and JUnit and whatever. Everything depends on these, right? And then Spring Framework sits up here. Spring Boot sits on top of Spring Framework. Spring Cloud sits on top of Spring Boot. And then if you want to do distributed tracing, well then you use Spring Cloud Sleuth. So Spring Cloud Sleuth does distributed tracing. Micrometer does metrics. But aren't they kind of two sides of the same coin, right? Like this is metrics, that's tracing. But if I want to see data related to the behavior of my application, I want to look at the metrics to see which endpoints are having trouble. And then I want to look at the trace logs to see a particular request that's erroring out so I can understand which server is slow and which one's having latency and whatever. So a big thing that we did in Spring Boot 3 is we have a new version of Micrometer where tracing and metrics are handled by the same library. Okay? So it's now lower level. That means that Spring Framework can depend on Micrometer. That means that Spring Framework and other libraries like Neo4j and the RabbitMQ driver and a bunch of others, all these other libraries can depend on Micrometer and they get this new API. So now they can export not just metrics, but also trace information. You send a message through your favorite broker, it goes from one node to another, now it's traced for you, if you want to. So you can plug in OpenZipGit, you can plug in OpenTelemetry, you can plug in all these different bindings and get trace information with the same API as you would for metrics. And in addition to that, they've given us a new unified abstraction called the observation. So let's go here and let's actually add some observations. Okay, here's our code, right? I'm going to use this new API to instrument this call. I'll say return observation, create not started, and I'll say just by name. It's going to require a pointer to the observation registry, so private final observation registry. And then I'm going to observe, in a context, in a scope, I'll return the result. So if, okay, let me see, if I, okay, there you go. There. So I'm observing this request. In this case, I'm not really doing anything interesting, but if I were making a network call to another service, then that would be automatically traced. If I was using the reactive web client or the REST template or whatever, that information, those clients would automatically be traced in the context of this observe call. Okay? So let's do that over here as well. Same thing. And we call this just all observe. Okay, here we are. Good. So I'm going to return that as well. So there we go. Those are my two endpoints. Let's go ahead and restart this. And now we'll go to our endpoint, our browser endpoint. Refresh, 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 refresh. Let's just get all the customers. Refresh, 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 refresh. I'm refreshing as fast as I can. It's going well. Okay. So now localhost 8080/actuator/metrics. And I want to get the all metric, right? Metrics/all. I can see here's how many requests I've made, the total time, the max time, etc. So this is just in browser, obviously. But if you're using Micrometer, you can send that over to any time series database. You can now visualize in one single place your trace information and your metrics, right? You have a single pane of glass. This is very important in visualizing what's happening in your production system. Okay, and of course by name. I have this one as well, right? You have metrics about this, and you can easily trace that stuff as well using Prometheus or whatever. Okay, so we've got metrics. I also love the health endpoint. This is not new, this health endpoint, but it's something that's kind of interesting. This health endpoint gives me the ability to understand whether my service is sick or not, right? So, the health endpoint has some basic features. You've seen this before, right? This is not new. Curl -v, and you can see it's showing me whether the service itself is up and healthy Kaki and all that. And it shows me whether the database is up, whether the file system is up, etc. There's also liveness and readiness states. The liveness endpoint tells me whether the service is still able to serve. The readiness endpoint tells me whether the service is ready to be put in production. These are for Kubernetes, right? Kubernetes expects when you configure a pod or deployment that you configure a readiness and a liveness probe. So these endpoints tell Kubernetes whether your service is okay. Well, how do you make it say that you're not okay? Well, you can use the Spring Application Context Event Bus. Did you know that Spring has an event bus that you can use to publish messages asynchronously from one component to another in the actual same application context? So let's suppose that I wanted to create a controller here. Add controller, class error, or down controller, there you go. And it's just going to be at response body, get mapping, down, void, down, okay? Good. So I can publish an event, and you can publish events, generally speaking, you can get access to something called an application event publisher. But here, I'm going to use an application context, and I'll use a convenient static method in Spring to publish an availability change event, right? So this .context, I'm going to say that the service is down, it's broken, okay? Good stuff. So I'm publishing an event saying that the service is broken, and that's pretty trivial. So that event's going to get published. The probe, the readiness probe and the liveness probe will see the new event, and they'll change their configuration to reflect that. So let's try this again. This is the health right now. If we go to liveness, everything it seems fine, right? Let me get rid of the verbose output there. There it's up, curl, down. Okay. And get that again, now it says down. So I called down, it published an event, it triggered that the output be down. And if I get this actuator output, oops, minus V, if I get this output, you can see that it's also returning 500 as a status code. So your load balancer and Kubernetes and all that thing, all those things will see that the service is now sick. Well, what happens now? Well, now Kubernetes is going to try and take your application, your pod, your deployment, whatever, out of the rotation, out of production. At this point, it's going to send a sig term signal, and then very quickly afterwards, it's going to send sig kill. It's going to take your process down. Sig term is a suggestion that says, please shut down gracefully. If you don't shut down very, very quickly, it'll send a sig kill. The problem is you might have in-flight transactions. You might have work that's happening, right? And that's a bit of a problem. You need to make sure that you gracefully taper off any existing work before your process gets shut down. And so you want a timeout, right? I want a timeout of 30 seconds, and then if it's still doing something, we can use sig kill. To get that graceful shutdown, you go here and you say shutdown equals graceful. Okay? So this will actually stop accepting new HTTP requests, and it'll allow your server to finish whatever it's doing, and then it'll shut down the application after 30 seconds. Make sure that you also specify the equivalent value in the pod or deployment for your application. Okay? So we can start it again, and then if I shut it down, it says there's nothing happening, but you can see it's now doing graceful shutdown. Commencing graceful shutdown, waiting for active request to complete, etc. Okay, so we have an application. It's got observability, it's got the actuator, it's got this new unified observation API, it's got some graceful shutdown, it's got robustness and error handling. We're making it easy to understand what the user is doing with complete, consistent, standardized error messages. I think it's time to go to production. And here, my friends, there's two concerns that are top of mind, two things that spring to mind. The first thing I care about is, obviously, how do I package this application? Well, obviously, this is not too big an issue, right? This has been supported for a while. You can use build packs. Build packs are a way to containerize your application. This is a Cloud Native Computing Foundation specification. And the idea is that you take an application artifact be it a .jar, a .war, Ruby on Rails application, Node.js application, .NET EXE, Python application, PHP, I can't do it, it's not a language, I refuse to admit it. We can take that too and turn it into a container, right? Easily. So there's a convenient command line tool called pack. And you can use pack to automatically turn these things into containers. But if you're using Spring Boot, you don't even have to do that, right? You can just go here and just use the Maven or Gradle plugin to build the image. That'll use build packs behind the scene. If you don't want to do build packs for every single build, you can actually deploy it into your cluster as a kind of operator called kpack. There's something called kpack that you can install, and it's build packs as a service. So you send it code, and it'll ship out a Docker container that you can then Docker tag and Docker push to your container registry of choice. So this is interesting, but that's not new. I just wanted to point that out. That's very interesting. What I care about is making my application as small and efficient and fast as possible. And we have an interesting opportunity, my friends, a new opportunity that really we didn't have 5 years ago, right? And this is the GraalVM native image compiler. Okay? Now, how many of you know about GraalVM? Okay, GraalVM is awesome. GraalVM, come on. GraalVM is a high-performance cloud-native polyglot runtime. It's a replacement for OpenJDK. It is based on OpenJDK with some interesting extra add-ons. First, it replaces Hotspot. It has its own just-in-time compiler. This just-in-time compiler takes your code and adapts it into native operating system specific code. This is an amazing piece of technology right here. I love that part about Java. That native compilation is amazing. The other thing that Java does, to make itself really fast, is the garbage collector, of course, right? I don't want to spend too long talking about that, but the garbage collector is one of those things that makes Java so fast, right? There's a reason that large websites, when they want to run in production, they use Java, right? The garbage collector is one of those things that I love about Java. It's one of the reasons why it's possible to take a Java application that just uses Java and have it go faster than a well-written C or C++ application, right? If you think about what most people are doing here, they have, some sort of startup scope, right? They malloc some memory in C. That takes time. They do something, and then they have free, which cleans up the memory. This creates like little bursts of memory, right? In regular C and C++ applications. In Java, it's much more smooth. You've got another thread in the background managing the memory. You don't have to worry about that. It's just all handled for you cleanly. So this is one of those things that makes Java so amazing, is the garbage collector. By the way, did you all see that amazing? We're in Southeast Asia. Did you see that amazing tweet from a woman named Jesselyn from Indonesia a few years ago? It went like viral. Let me see here. She is the original Java garbage collector. I am from the island of Java, Indonesia. I am the garbage collector. There it is, right? It's awesome. So anyway, she's the original one, but after that, Java's pretty amazing too, So anyway, the garbage collector is one thing. Nothing more needs to be said about that. But the just-in-time compiler is an amazing piece of technology as well, right? That just-in-time compiler takes your application and turns it into a native operating, it turns parts of it into native operating system specific code. That's not new, right? I think you all know about that. So for certain parts of your application that are run many times in fast succession, Java will turn the code into native operating system specific code. Binary, right? Like assembly, basically. This can result in applications that are really fast, right? It's one of the reasons why large websites like Google and Alibaba and other huge organizations use Java in production because they know that they can do this. They warm up the JVM. They'll deploy a JVM instance hit it with some traffic within the organization just to warm it up, and then once the JIT, the just-in-time compiler, has run, then you'll turn it on and allow production traffic, right? This is an amazing feature of the JVM community, and the JVM itself has got this amazing superpower. So the question then is, if the just-in-time compiler is so amazing, then why don't we just proactively compile everything into native operating system and assembly, right? It's a good question. And part of the reason is that there are some limitations on what can be turned into native code, right? In order for this to work, the just-in-time compiler needs a closed world. Oh yeah. It needs a closed world. It needs to know that what's in the code won't ever change. It's not going to do something funny that will be unexpected. And so there are things that you can do in Java that are very dynamic, that run afoul of the idea of a closed world system, right? Java is a very dynamic language. For all of its syntax and verbosity and all that, even though it sometimes feels like C++ or C or something like that, it actually has a lot more in common with the likes of JavaScript and Lisp and Lua and Ruby and Python and all these very dynamic languages. Most languages have something like this, eval, where you can pass in a string, right? One plus one, and you get a result, right? Result. Come on, Josh. So that's like JavaScript, for example, right? Well, in Java, you can actually do something like this. It's not nearly as concise, but you can actually do something like this. You can actually evaluate a string, turn it into a class file, load the class file into the class loader, reflectively create a new instance of the type in the source file, call methods on the new type, create an instance of it. You can serialize it. You can create proxies out of it. You can do all of this stuff after your application has already compiled and started running, right? So Java is very, very dynamic. And this is hard for a native image compiler to see. So GraalVM has a just-in-time compiler, but one of the things that it also has is a ahead-of-time compiler. And this is a new feature. This native image compilation mechanism allows you to take your JVM applications, you provide some configuration that tells GraalVM about all these dynamic use cases, like JNI, like serialization, like loading things from a class path, like proxies, like reflection. And if you do that, if you provide all this configuration to tell it about all these dynamic use cases in your Java code, it'll create a full native binary for your application. And the result is amazing. Let's go ahead and take a look. So I'm going to go here, Maven -p, native D, skip tests, native compile. Okay? So we're going to let that run. And the problem is, this is going to take a little while. This actually takes a long time. And so, I want this to go faster. And so I went to the GraalVM team and I filed an issue on GitHub, right, on the Oracle Graal project. And I said, please, play elevator music during the native image compilation. And I said, in my head, I already hear elevator music. So why can't we just have that while the compilation is happening? You know what this reminds me of? Did you ever see that XKCD compiling cartoon? Right? This is an old cartoon, and they're talking about like C++ and C and all that. But yeah, the number one excuse for programmers who are slacking off. Hey, what are you doing? Get back to work. We're compiling. Okay, keep going. Carry on. Right? This takes a long time for like real sizable native code. Even iOS, right, takes a long time, and so on. So Java, we don't have that problem. Java is very quick. It doesn't take half an hour to compile a regular JVM application. So I wanted some elevator music, and other people, they like the idea, they voted for it. I want you to vote for it as well, right? Let's make this happen. And other people even got into the act, and they said, okay, hey, how about we use this elevator music? What is this one? I like that. So, somebody has said, well, thank you for your feature request, Josh. The problem with this is that it's just fixing the symptom, and they really want to fix the problem, which is that it takes a long time. He did, however, prototype something. He prototyped a Josh Long mode. Right? This guy is Fabio Niepaus. Woo. Fabio Niepaus. He's a researcher on the Graalvm team in Oracle Labs. So he's like legit, right? He's a PhD, he's a doctor. He's one of those people that worked on the ASCII artwork, right? And so anyway, he built an ASCII artwork, he built a Josh Long mode, and it says, music brought to you by Josh Long. And there's the ASCII artwork that would get printed out while you're waiting for the compilation, while the music was playing. I think we need this. I think this is the feature we deserve. It's not the feature that we want. So, anyway, I guess he's pretty pessimistic that it won't get accepted, which makes me sad. Anyway, it finished compiling. Here it is. It took a minute, which is a long time. So, service, run. So there you go. There's the application, right? Did you see that? Did you see that? There's the application. There it is again. You know, really, really good. Faster than a light bulb. Light bulb, click on, right? So, good. So there's the application. It started in 82 thousandths of a second. This is much better for serverless. Not the animated one, right? Animated GIF, no. This, yes. Now, this is very fast, and of course everything still works, right? So you go here, here. You can see the data is all there, right? Refresh. Go to here, Josh. That data comes back. It's working just fine, okay? Everything is working as we expect. This is a big feature that we've worked on in Spring Boot 3 and Spring Framework 6. Nothing special required to make this work for most of the use cases. Now, big asterisk there, right? We're hoping that this will work for you just out of the box. And this will be production-supported, GA-worthy code in 2 weeks, right? Now, this application is fast, but who cares? Because this is just a web app. You can do serverless, by the way. We have Spring Cloud Function. You can use Spring Cloud Function and deploy lambdas and all that kind of stuff. But for this is just a web app. So fast startup time, I don't really care about that. What I do care about, however, is the memory footprint. Memory is an amazing thing. So if I go here, I have a little script. Right, there's the script. And it says ps-o RSS pip. Okay? So it's basically just evaluating the resident set size of the process ID. And the process ID for this application is, where did it go? Here. Okay, I'm going to take that, paste, 106 megs of RAM, right? For reference, I don't even, well, yeah. I mean, just think about it, 106 megs of RAM. What takes 106 megs of RAM in your life? Do you know how much Slack takes? Right? When was the last time you looked at the memory for Chrome? Don't look at the memory for Chrome. It's terrifying. So, yeah, 106 megs of RAM. Again, you're among friends here. Be honest. How many of you take a gigabyte for your JVM applications? Just 1 gigabyte or more. Who's using more than a gig for your Java JRE applications? You're all doing less than a gigabyte for your Java applications? Nobody. Who's using a gigabyte or more for your Java JRE applications? Okay, see, some honest people. Who's using 2 gigabytes or more? Yeah, more people. Yeah. So, I'll tell you a little story. In 2004, I remember just being very surprised by how much memory all these applications I was seeing were using. 2004 is 18 years ago. Back then, everything was still 32-bit. right? So today you have like 32-bit operating systems. I mean, even my phone is 32-bit, right? It's 64-bit, right? But back then it was 32-bit. And the JVM was compiled for 32-bit. So it wasn't efficient to address more than 2 gigs of RAM on the JVM. And you'd see garbage collection pauses, right? It just wasn't very efficient. So 2 gigs was like what every application was taking. And there's this whole like movement to find ways to take more because these applications were taking up so much space. So the idea that 18 years later, with larger pointer sizes and page sizes, I can now just write a JVM application, a real JVM application that takes 100 megs of RAM. Masterpiece, amazing. So this is good. I mean, think about it. If your JVM is taking a gig of RAM, which is a nice, polite, indulgent, generous estimation. Let's assume it's only taking a gig of RAM. Then this is 10 times cheaper to run this and deploy this in production. This is what you want in your Kubernetes cluster, right? And I will tell you, this is not a free lunch. Nothing is perfect in the world, right? Running a JVM application with GraalVM, the garbage collector is not as fast. It's slightly slower. It's a little bit slower. That number is getting better, but that means that your ability to create objects and then clean up those objects will be slightly less than on the JRE for the moment. Who knows what that'll look like next year or the year after, whatever, or next month. But who cares? Just deploy 2 of these, right? Like if the throughput is, let's say, for simple math, let's say you can do 10,000 requests per second on the JRE, and on this you can only do 7,000. Then fine, just deploy 2 of these. You can handle 14,000 requests per second, and you're still saving 80% capacity, right? That's a good deal. It's a good deal. And of course, if you want to build a native image in a Docker container, well, do what I just showed you, right? Spring boot build -image. There you go. I'm not going to run it because, again, okay. So we've got our application, we've got our service, it's up and running. I want to build a edge service, a client that will talk to that service, okay? So this edge service, is going to be it's the first port of call for our service. It's going to be the thing that talks to the service that we just built. So I'm going to use the reactive web support. I'll use GraphQL support. I'm going to use Spring Cloud Gateway support, okay? I'm going to use Spring Boot 3.0 snapshot again, and of course I'll use Java 17 or later. Hit generate, and then open this up in my IDE. Huh? No! Who did this to me? The horror. Okay, UAO, edge.zip. Thank you for saving me, dear audience. I mean, you saved yourselves too. Quaidel would have had to download everything again. And we would have had to wait and watch. Okay, so this is my edge application. I'm going to use the latest and greatest, so I'm going to use Spring Boot and Spring Cloud Snapshot, okay? So let me just update that right now. Okay, good. So what I want to do in this edge service is build a client to talk to the service that we just built. And I could do this the old-fashioned way. I'm going to build a client that talks to the service. In order to do that, I'm going to do something terrible, something that you should never ever do, not even when you're all by yourself at home and no one is looking. I'm going to copy and paste code. I'll go down here, I'm going to copy and paste this customer, voila, okay? There's my client. I'm going to build a simple client. I'll say customer client. And in order to do this, I'll use the reactive non-blocking HTTP client. It's just a regular Spring Bean, and I'm going to create an endpoint here. I'll say return a reactive stream of all the clients, and then return a reactive stream of all the customers, by name, right? So string name. And I'm just going to use the non-blocking HTTP client. You could use the REST template, but the reactive non-blocking client I think is a much better choice for almost every use case these days. So I'll say customers.retrieve.body2flux customer.class. Hello. And here, I'll say return customer's name, okay? Passing in the name. So that's pretty straightforward, right? I think we can all understand what's happening there. So I can use this now and just create a simple Spring Bean. It's an application listener, right? Application listener. Sorry, application ready event. Sorry about that, ready event. Application ready event listener. And just I'm going to inject that client that we just created, customer client. Okay, and I'll just say customer client dot all dot subscribe. And I'll just print out the results. Okay, so system out, print line. Good, good. Okay, let's restart this and then see what this gets. I want to run this on a separate port though. So port will be 9090. Restart. Okay, I forgot to define the web client itself, no problem. Return this. Good. Okay, there we are. It worked. Of course it worked. It was a demo. Now, this is fine, but this is still pretty error prone, right? It's easy to make mistakes with this. It's easy to introduce bugs because you have to duplicate this logic, and every single microservice that wants to talk to my API has to recreate this client. So instead, there are some alternatives. In the Spring ecosystem, we have three options actually, and it's very confusing. We have Spring Cloud Open Feign, which is for HTTP. We have Spring Cloud Square Retrofit, which is for reactive HTTP. And we have Spring RetroSocket, which is for RSocket, which is also reactive by default, right? But what about, which one what if you want to do all three? Or what if you want just use reactive HTTP? Do you have to, can these things work together? No, they're all completely incompatible with each other because they're based on different underlying libraries. So in Spring Framework 6, we created a new thing. And the way it works is you create a declarative client based on an interface. And you define the endpoints that you want, like this. Flux of customer by name, string name. Okay, and you have to annotate using get exchange, not get mapping. Get mapping is for the server side. This is the client side mirror image of that. Okay, so get exchange customer's name. And of course, this is the path variable. Right? I'm going to use the server-side path variable annotation there. And this interface defines the client. I want to automatically create that bean instead. So I'll say bean customer client. I'm going to use the web client builder here. I'll just inject the builder directly. Actually, I'll just inject the web client, right? Web client. And here, I'm going to make the web client have a base URL. So localhost 8080. Okay, and here I'll say return HTTP service proxy factory builder bar web client adapter dot for client web client dot build. Okay, so I pass this in, and then build, and then create the client out of this. Okay. So that's all I'm doing. I'm just defining a client declaratively using this interface. And I'm providing a web client as my thing here. And you could also just inject this web client builder directly here instead of creating a separate bean. That works as well. And everything else is the same. I'm just going to rerun this. Okay, there we go. So there's our declarative client. And there's also a similar mechanism for RSocket. So now you can just package that one bean and that interface in a jar, distribute it to your teammates, and now they can all talk to your service with ease. And it's very lightweight, it's not hard to maintain and all that. Okay? Now this is one way to connect your client to your services. Another might be to use an API gateway. An API gateway is like a cross-cutting, it handles cross-cutting network concerns. API gateways are great for connecting different microservices. especially when you want to act on the envelope of the request itself. Rather than changing the payload, you want to change the envelope by which that payload is conducted. So we're going to use a project called Spring Cloud Gateway. Spring Cloud Gateway is awesome. I love Spring Cloud Gateway. So the way it works is you define a bean of type route locator, gateway, route locator builder. Okay, return RLP.routes. And the way it works is this application, this service is running on port 9090, and I want to define how to connect my gateway on port 9090 / proxy. I want to route that to port 8080 customers. Okay? Just as an example, I'm going to proxy the data. So the way it works is you create a route, and you use the route spec path proxy. Here's the predicate, and you can add to your predicate. You can do all sorts of things. You can say, okay, well, if this cookie is there, or this header, or this whatever, all these things you can do. Or you can just have your own predicate, right? New predicate matching the request. So here's the predicate that matches the incoming request. If that works, then I want to send the request to localhost 8080 / customers. The problem is that the incoming request, the path on the incoming request is proxy, but the path on the outbound URI is customers. So what I'll actually get is, localhost 8080 / customers / proxy. Doesn't exist. I need to change the request, because the request that comes in, it gets forwarded identically with no changes to the outbound URI. In order for that to work, I need to use a filter. So a filter spec, set the path to be customers. And hey, while I'm here, maybe I'll do something else. Maybe I'll add a response header to support cores, right? This API gateway, these filters are what's really, really amazing. These filters are what makes Spring Cloud Gateway so powerful. You can do token relays, you can do secure headers, you can do rate limiting, right? There's a rate limiter there. You can do all sorts of stuff here. I've just begun to scratch the surface, just beginning, right? So, let's see, okay? Let's go ahead and run this and see what happens. So, now, let's see, curl HTTP localhost 9090 proxy. I get the data from there, right? Pretty easy. And of course, if I look at the data and the output here, access control origin is now able to asterisk. So I've added core support. You can do rate limiting, you can do redirects, you can do retries, you can do routing and compression and security. All this stuff becomes trivial to configure with Spring Cloud Gateway. Also, all of this works in native, sort of. Let's just try it. Fingers crossed. It's been one of those days, flip a quarter, maybe it works. All this stuff is coming together right now, put it that way. So here we go. Let's go ahead and try and make it all work in native. Maven, P, native, D, skip tests, native, compile, and go. And of course, this is also a good time for elevator music. Anyway, so that'll take its time. In the background, what that's doing, and we're going to see this in a second, in the background, that's actually preparing the Spring application by transforming it so that it gets fed into the GraalVM native image compiler in a much more efficient fashion. It skips a lot of the things that GraalVM hates, and it provides configuration for the things that are still there that we cannot avoid completely, right? So the result is that you have an application that just works in GraalVM. Let's just see how this goes. Come on. RAM on this, by the way, activity monitoring. Oh, it's gone. Well, here's the edge application, CD target, edge. Oh boy, here we go. Zoom. Okay, there it is. That was actually very slow. Let's try this again. There you go. For some reason on the Mac, that first run is slower than the second ones. This doesn't happen on Linux. I don't know why. It's just always fast on Linux. So, whatever. Okay, so anyway, there's our edge service. Let's see if everything's still working. Localhost proxy. That's working fine, right? Proxy. 99 proxy. And then what was the other thing we did? Oh, the declarative client. Yeah, the declarative client is working as well. The interface-based client. So that just works out of the box. Now these are two of my favorite ways to connect your client to your downstream services. My third favorite way is to use GraphQL. Now GraphQL is a very neat API. How many of you have heard of GraphQL? Okay, it's a great way to build APIs. So here's an example. There's lots of open GraphQL APIs. Here's one from a company in the States called SpaceX. They do space, whatever. So anyway, I know. Trust me, I know. But anyway, they have this API, and this API is really cool, actually. I mean, look at this. You can see some of the cool parts of GraphQL in action. Let's say I want to get the last launches, okay? So I go there, and I say I want to find the last 10. And I then ask for some data back. Well, I want the IDs, okay? Great. But what if I want the details? Enter, great again, right? So I'm getting more or less data in my request based on what I asked for. What if I want to know more about the company? Okay? Like, who's the COO? Okay? So now, I'm getting both the company information and the launches. Well, these are not the same microservice, right? There's no way they have the same schema, the same database for both of these. There's probably different microservices. Conceptually, it makes sense that there would be different microservices. And in fact, if you think about it, all of these could be different microservices. But notice that already that I have some interesting benefits by using GraphQL. First of all, I have schema, right? You can see I've got types, I've got schema that I can look at and get control IntelliSense. I can hit control space and see and navigate the types. Notice that I also have validation. So if I go here and I ask for the, let's say I go to, I don't know, capsule. No, that's what's it called? Oh, here, actually, just go to the company. If I don't ask for anything, see, look at that. It says, I've got an error. You have to ask for something. You can't just get the whole thing, right? So if I try and just run this, it gives me this. It gives me an error. It says, no, that doesn't work. Okay, so what about the CTO? Great, right? Get that back. COO. Okay? So I get that back, right? I get validation that I'm making a valid request. I get introspection. I get enumeration of all the services. I get discoverability. This is very good for a microservices situation, right? Now, Spring has support for GraphQL. So let's build a GraphQL endpoint. To do that, we start with the schema. So I'm going to build a new directory here called GraphQL. I'm going to put a file in there called schema.graphqls, right? And in GraphQL, you have three operations, right? You have queries, you have subscriptions, and you have mutations. Subscriptions are how you read finite data. Subscriptions are how you read ongoing, unlimited data, right? Streaming data. And of course, mutations are how you change things. Delete, add, save, update, right? All that you do with mutations. It makes it really simple. This is what I love about GraphQL. That's it, those three verbs, that's all you need to know. Now you can solve all API problems in terms of those three verbs. This is different from REST, right? REST is great. I like REST but I've been using it for 15 years. I know how to do it, almost, right? Like, I'm almost there. I can feel it. But even now, I still sometimes get confused. Should I do an HTTP, what if I want to save something? Do I do a post? A put? Should I implement options to make sure people know about it? When I do a post, should I do 200? What if I want to add something that's, a new record? Do I do a 201 and a location header? Or do I do a 202 if it's a very big thing? And then I have a location for the status, right? So this is the location of, by here, it's location of entity, isn't it? And this is to check on creation, right? And then that'll return status as well when it's done. All this stuff, I don't know anymore. And then all of this ignores hypermedia, right? Hypermedia is very important. You gotta be very careful. You gotta do hypermedia. You gotta look at things like hypermedia as the engine of application state, which is HDOS, right? Yeah, exactly. Yeah. Do you know about this stuff? Because if you don't, you're doing it wrong. That's what they'll tell you. You're doing it wrong. And this you get the Restafarians, right? You really want rest to be a certain way, otherwise it isn't rest, right? That's why in all this code, you see this? In all this code, I don't even say, look, I just say customer HTTP controller. I didn't say customer REST controller. I didn't want to make anybody upset, right? So GraphQL is great because you don't have this worry. You just have mutations. That's it. That's all you have to worry about. You want to change something, you use a mutation. If you want to read something, use a query. You want to read something that has streaming data, you use a subscription. That's all. So let's go ahead and now build our own custom GraphQL endpoint here. I'm going to start with this schema file. Remember those three verbs, mutations, queries, and subscriptions. Those are represented by types. For a query, you have type query. Okay? All root queries live on this root type called query. And I want to create an endpoint that returns a field. This is called a field. I'm going to create a field that returns all the customer data. And another field by name that takes a parameter, an argument, and it returns an array of fields. So an array of customers. This bracket, if I don't have a bracket, it just means a single result. If I have a bracket, it means an array of results. The name of the field is here. The return value is after the colon here, right? So here I've got a field with no parameters or no arguments. This field has arguments, okay? So let's go ahead and implement that right now. Let's go ahead and just implement that first. Actually, I'll do it up here. So class customer GraphQL controller. Okay, it's just a regular Spring controller. And notice that this entire time, we're using the Spring Framework's annotation called controller. Same one. You can use the same one for RSocket, for WebSockets, for reactive and non-reactive HTTP, for service and event streams, for GraphQL, for everything, right? It's the same protocol. This is not tied to the web. It's just a generic annotation that represents a component that takes business logic and adapts it to a protocol. That's it, okay? So we're using this annotation here to create a GraphQL endpoint. So I'm going to create an endpoint here that returns customers. And I'll create another endpoint here that returns customers by name, string name, okay? And of course, I'm not going to re-implement that. I can just use my declarative client. I'll say customer client. Good. This dot customer client dot all. Okay. This customer client dot by name. Okay. Now we need to map this. So here, this is a field resolver on the type called query, right? And the name of the field is called customers by name. And likewise, this is a field resolver for customers, all of them. And this customers by name has an argument. So we need to specify that that's the argument by using the argument annotation. Now I want to try this out, so what I'm going to do is I'm going to go to my properties, and I'll say graphical enabled equals true. Okay? So I'm going to enable a console to try it out. Let's go ahead and restart. What just happened? Schema. Oh, I didn't define the type called customer. You have to define it first. So ID, name, string. Goody. Okay, so localhost 9090 graphical. Okay, so this is a console. Let's close these out. Query customers ID. There we go. There's our records being sent from across the microservice. Okay. What about the name? Great, I want that as well. There we all are. Okay. What about the customers by name? Halfway. Okay. There you go. Okay. So you can get the data. You get as much or as little of the data as you want. Very, very convenient. Okay, so we've got this GraphQL endpoint. Now, let's talk about some of the problems here, or some of the ways that we can improve this. Let's suppose that we had another microservice. Okay? We had another microservice, and instead of just a customer record, we also had account data. You know, maybe there's some username and password and all that stuff tied to an account. So we have customer data for like booking and fulfillment and sales and whatever, but there's also online web account. Okay? So I want to change this schema to introduce a new type called account. And here we're just going to create username is a string. Okay? And I want each customer to have an account. Now, of course, I didn't build the customer service to have this account type. There's no relationship in the back-end implementation to an account. But in the GraphQL, I'm going to present it as though there is one. So let's implement that here in this code. Record, account, string, username. Okay? And here, I'm going to create a new schema mapping. Type name is equal to customer. Field is named account. I'll say account. Now, how am I going to find out the account for the customer? I need the reference to the customer to find out what account belongs to it, don't I? So I ask GraphQL to inject that customer for me. I can say, okay, new account, whatever. The ID will be, let's go here. It'll have an integer ID as well. Okay? So the ID will be customer.id and customer.name account. Whatever, I don't know. We can figure out that later, okay? So I'm using the customer to inform this. Now obviously use a DB or microservice to look up the customer data, okay? We get the idea. Let's go back to our schema here. ID. Let's restart. Okay, so we'll go back to the console. Refresh. Okay. Paste. Okay, so everything is still working, but if I want the account data, I can ask for it, but I have to specify what subfields, right? Field account, type account, must have a selection of subfields. And then it asks me if I meant to specify, for example, the username. So account, username is the account, right? And same thing down here. Maybe I want that account data down there as well. Let's go down here, account, and maybe I just want the ID in this case. So there's the account ID for each user, for each customer. So I'm creating a graph of different APIs. The client doesn't know that these are two different services. It doesn't care, right? I'm able to provide a consistent federated view of the world and I can change things in the back without having to worry about it. Now the problem, of course, here, is that this is fairly inefficient, isn't it, right? Like, I mean, imagine if this was actually a microservice call to another network, right? This would be n plus 1, right? We don't want that. This is n plus 1. That's not good. Also, this is fairly verbose, don't you think? This whole annotation. Remember what I said earlier. Queries and subscriptions and mutations are common cases where you will always have one or two or all of these in your application. So let's first of all simplify this. We can use query mapping, right? The type in this case is automatically query, and the field is derived from the name of the method. So that is the same as this. Okay? Good, much better. Same thing here, query mapping. Okay? And of course, here we keep the schema name, but we don't need the field, because again, that's derived by the name of the method. So that's much cleaner. So this is still a schema mapping, because it's a custom type. It's not query, right, of course, but everything else is the same. Now, what about the n plus 1 problem? Here, I'm getting all the customers, and then for each of the customers, getting account for customer, customer.id. Okay, let's restart this. Okay, go here. I'm just going to refresh. Okay, so I got all the same data as before. Let's go and look at the logs. You can see it's getting the account for each one of those. That's a separate network call, right? That's not very efficient. So what I want to do is I want to get rid of that extra call, and I can do that with batch mapping, right? And so what this does is the contract is, given a customer, you return an account. So I'll return this, and I still have a list of customers. Okay? Map, and just as a simple example, I'll say map of, or just a new hash map, I guess. New hash map, customer account, turn map. So map.put, and then for var c customers, map.put c, and new account, right? So same as before, whatever, just id c.name account. Okay? And now I don't need this one. I can just remove this. Restart. Okay? So go back here, run the same code. I got the same results, right? Account 1, Josh, blah, blah, blah. And the console is not printing out anything anymore, but you can see it's obviously used this instead, because I commented out the other one. So now I only have 2 requests. I have one request to get all the customers, and another request to get all the accounts for all the customers, right? I can do something like select all from customers, select all from accounts where customer ID in, and then provide a list of customer IDs or something like that, right? So now you can get rid of it. Sure, yeah. So now you can do all this kind of stuff very dynamic, very quickly, very efficiently, okay? Now, friends, I've got a GraphQL endpoint. The real question, does this work in native? Kinda. So, we're working on it. It'll be done soon. But in the meantime, we can still make it work. I just have to show you some stuff. And this is okay, actually. I'm kind of sad that this is going to be fixed soon, because then I won't have a built-in easy way to show you something that I want to show you, which is, what do you do if the thing you're using doesn't work with GraalVM already, right? So remember I told you that GraalVM hates Java code, and it hates fun. It hates it very, very much. And you need to tell it about all the places you're having fun, so that it will still work when you do those things. And so the easy way to do that is to provide config files, right? I told you that's what's common. So I'm going to do that here for GraalVM. Copy desktop, Spring Boot create AOT GraphQL, source main resources, meta inf, downloads, edge, source, main, resources, meta, inf, okay? Oh. Good, so there's the first way to do it, right? You have to create these config files that tell GraalVM about things that you're going to do reflection on, for example. Here's reflect config. I'm going to reflect on these types. I've got 5 or 6 types here that I need GraalVM to know about, right? I want reflection to work for those types. I'm also going to load these internationalization files, I18 general, I18 parsing. These are internationalization bundles in my jar, okay? That's it. So that's all I need from GraalVM to understand what to do with GraphQL Java. There's also a little bit more to make our controller work. And here, this is where we get into the Spring component model. That config file is fine, I guess, but think about what happens tomorrow if somebody refactors this name. Does my config file get changed? We don't know. I hope so. Hopefully your IDE is smart enough to sync up the two. But if it doesn't, then you're going to have something that falls out of sync, and that's a bit of a problem. So in Spring, we have a component model that you can use to programmatically generate that configuration for you. And it's based on your types. So you can refactor your types and have new configuration as a result. So we'll say class, GraphQL hints implements runtime hints registrar and say register hints. Okay? So this is a compile time type. It's a Spring type, but it gets evaluated at compile time. And you have a choice and a chance to register custom hints. So I'm going to do that here. Desktop, Spring, AOT, GraphQL, source, main, Java. Here, copy these types. And, I'm going to register customer GraphQL, Java, and of course account.class. And I'm going to register this as well. So here's my custom hints, right? I'm saying I want to programmatically register. A reflection hint, right? I'm registering a reflection hint there, and I want to programmatically register a resource hint, okay? Now this type, I need to import, so I can just add this like that, okay? So that'll make GraalVM aware of this custom stuff that we're doing. This stuff you won't have to do soon, right? This will be done for you. And so will the JSON config files. So it's not even that bad, but you won't have to do it eventually. But for our demo, we do have to do it for the moment. Give me a few weeks though, things will be fine. So Maven, D, skip tests, P, native compile. Okay, run. And this will take another minute or so. And so to understand what's happening, let's take a look at the generated target directory here. At compile time, we actually create a skeletal bean factory full of all of your beans. And we run these hints, callbacks, and other types against your code, and we generate new code. So here's actually the generated code for our application with all of the Spring beans in the application context. Here's the gateway, the web client, the customer client. These are functional registrations of all the beans in the context that actually create a more efficient version of the context. We don't do reflection, we're not doing component scanning, we're not doing any of that stuff. It's just being, we're given a bean factory and we register all these things directly. This skips a lot of the inefficiencies, and it also means that we have to have much less configuration. If there's still some places where we need configuration, Spring also generates that for you, right? So here it is, resources. You've got resource config, reflection config, proxy config, etc. All that gets generated for you at compile time, and it gets fed into the GraalVM image. So it's the same application, it's just, different. Okay, target. Here we go, friends. Fingers crossed. Okay, declarative client works. Does this work? Fingers crossed. It works. There's the GraphQL endpoint working. All right, my friends. This is fun. We talked about 3 of my favorite ways to connect outside services to our downstream data. We looked at Spring Cloud Gateway, we looked at declarative HTTP clients, and we looked at Spring for GraphQL. We also built a service that talks to a database and uses SQL, and we looked at observability, the new observation API. We looked at GraalVM and the Spring AOT support. And by the way, like I was just in Thailand, and in Thailand, you know, I was very surprised. I thought they were very excited about ahead of time compilation. Airport of Thailand. So it's apparently not the same thing. But anyway, like all this stuff, GraalVM, AOT, the new observation API, Spring Boot 3, the new Jakarta API, the Java 17 baseline, the actuator support, the new micrometer tracing support, GraalVM support, AOT, you know, all that stuff we've just looked at, and we've only just begun to scratch the surface. Obviously, there's a lot more we could look at tonight, but I'm afraid, my friends, we're just about out of time. I want to say thank you so much for coming out. Who learned something new? Who learned something new? Good stuff, good stuff. Rock on. Who had fun? All right, good stuff. Thank you so much, everybody. Appreciate it. Oh, good. Nice to hear.
Alright, it's the moment you all been waiting for. Before you go to that, yeah, how many of you here are converting to Java soon? Oh, good, we've got a few converters here. Very good, very good. Okay, so hopefully everyone got your t-shirts already, your stickers. By the way, do you guys know the t-shirt is actually limited edition, a collector's item, because there will only ever be 250 units ever printed. So for those of you here who attended the event today, the t-shirt is also made with Uniqlo Supima material. If you watch the t-shirt label behind, right, it's actually Uniqlo brand. So for that, we have to thank Vmware and partners. Thank you for the wonderful menu, wonderful food, and the wonderful door gift. Okay, making this happen. Okay, and thank you, Josh, as well, for during a very long and informative session. That's really nice.
Thank you.
Big thanks to you. Okay, so before you leave later, also after this giveaway, number one, number two, we have also invite Eric to give a closing speech. Then we have a group photo. Okay, everyone stay for group photo and group video. And then, yeah, let's move on to the giveaway right now. Okay, so for the giveaway, let me figure out how to switch the screen. Alright, fantastic. Okay, everyone, get ready your headphones. But before we start, let me introduce you the prizes and also the rules of the game. Okay, so today our sponsors have provided us a very generous budget. Let me introduce you, there's 8 prizes in total. Okay, 8 prizes in total. And I'm sure the one first.
Oh, that's awesome.
Okay, there's 8 prizes in total, so I'll go introduce the prizes from the 8th prize onwards. So for places 6th, 7th, and 8th prize, you'll be getting a Logitech G502 gaming mouse. Can I hear some applause? Okay, and then coming in the 5th place, if you win 5th place, you win this speaker. It's a Logitech 7333 2.1 channel speaker, 80 watts. Okay, that sounds good. And 3rd place and 4th place, you'll be getting the MX Masters 2S. MX Masters 2S, who wants it? Oh, not many people, surprisingly. Okay. Alright, and the last two gifts, 2nd and 1st place. So it really depends on the ranking later. Okay, depends on the ranking later. Make sure you use your full name, all these short form names. Bro, why you use the short form name? How will you find you later? Okay, so if you still can modify, please modify. If you can delete use your full name, that will be the best. Okay, and the last two prizes for 1st and 2nd place is a Keychron K6 wireless mechanical keyboard, aluminium body. I purposely choose the hot swappable version. Okay, I know what you guys want. Hot swappable version, so later 1st and 2nd place, one will get the red switch, one will get the blue switch. Right? Okay, so the rules goes like this. There will be 8 questions on calculator, very short. Each question is about 30 seconds. Okay, each question is given 30 seconds to answer. And the fastest to answer the most correctly wins, you get the ranking, right? Okay? So from the ranking at the end, you'll call the names from 8th prize onwards to come collect the prizes in front from Speaker George and Andre here. Okay? Is everyone ready? Please don't use anonymous names like this. Whoever doesn't use full name, I need to call the next one, the next full name. Okay? Still can modify. 123 participants, 127. Okay, I count to 20, I count to 10. Make sure you all, I'm going to start the game now. Baru ada few kan? Okay, 134. Please use your full name. Alright, counting down. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Alright, let's begin. What is Josh's second favorite place on the internet? You got 30 seconds. Come on, come on. Take a guess.
Second favorite.
4, 3, 2, 1. Whoa! Very good. Jaws 10. Okay, now let's continue. What is the new required baseline version of Java required for Spring Boot 3? Wow, you answer that fast, huh? Hey, wow, almost everyone got it right. Who answered Java 32, by the way? does AOT stands for? Wow, a lot of people answer wrong. This one, very surprising. Okay, very good, very exciting. Okay, next one, multi-selection. What is the easiest way to get around GraphQL VM's lack of Java agents? Let's see. Oh, okay, not bad, not bad. And then oh, okay. What is the easiest way to build Docker containers on Spring Boot applications? Everyone of you here very active can get most of the questions right. Let's see what's the leaderboard right now. Oh, a new leaderboard, completely different. Wow, very surprising, man. Totally different names. Okay, here comes the tiebreaker. The answer is right in front of you. Down here in this banner. Okay. Okay guys, last question, final chance to change your fate. Multi-selection. Who are the sponsors for today's meetup event? Multiple choice selection. time for the final results. Are you guys ready?
第一个就是
Third place, second place, and the first place is Martin Wong. Alright, let's see the full English and start calling the names out, okay? Let's see if we can get the full top 8 winners. There you go. Alright, so here's a full breakdown from placing number 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're starting from Ayers. Okay, I think we'll start with Patrick first. Okay, so we will start with 3 by 3, okay? So first we call Ayers, the winner of the G502 gaming mouse. Ayers, are you here? Sure, Patrick will be passing the prize to the winners. Go at the camera. Josh will present the later prizes. Right, look at the camera. Next is Yudish with the E. There's 2 Yudish here. Alright, next we have Farid Alas. Coming from behind. Go to the camera. Alright, next prize, we have the speaker. And the winner for the speaker is Lim Carmen. Yeah, you guys have been surprised why the 5th place is happier than Alright, next I'll invite Josh. Josh to present the next 4 prizes. Okay, the next winner is Vinci. Alright, enjoy our next master 2S. Okay, next after Vinci is Chuong New Bin. Alright, and our last 2 prizes. The most exciting one, the one everyone wants. Marcus Wong Kim. Only one question. Marcus, do you want the red switch or the blue switch? Red switch or blue switch? What do you choose? Okay, good. That's the one. Alright. Take a picture. And last but not least, our first place winner, Martin Wong. stage over to Edric for closing speech.
Alright, so everyone here still concentrating, waiting for drinks? No? So everyone here learned something today, I hope? Yeah. Right? Like the event? Great. So this is actually the first collaboration with Kaki, as I said. So, I don't know what's happening to the mic. But yeah, so we are hoping to actually have more of such events, right? So we'll probably be sharing some of the upcoming events and so on. Could be online, could be physical like this. So we want events, right? So we would also like to hear from you guys. What type of topic do you want us to actually cover more, right? So today we have 2 hours of just time to share about spring. But we can actually go deeper if there's a need to. So it all depends on you guys. So we will probably send out some of the survey and so on later on to kind of have you guys, share your thoughts, what you want to hear about. Right? So, and of course, as I said just now, we have actually shared some of the slides saying that we actually do share a lot of free education for you guys. So do you